Hi, I'm Shelley Jones. Welcome to Learning Math with Dr. Jones. Our Facebook group will post a daily math lesson Monday through Thursday at 1 p.m. Eastern Standard Time throughout the month of August.
All right, so the distance between 2 points. So we could use the Pythagorean theorem in order to think about the distance between 2 points. And the Pythagorean theorem is c squared equals a squared plus b squared. Now, in your book, I don't think they went straight to the formula, but they talked about how the hypotenuse is always opposite the 90-degree angle. And so the Pythagorean theorem works for right triangles. So you need to have a right triangle which has one 90-degree angle, and your hypotenuse is the longest side, and it's opposite or across from the right angle. And then you, of course, have two legs because you have a triangle has three sides. So one side is the hypotenuse, which is the longest side, and then you have two legs. I named them A and B because the c squared equals a squared plus b squared. Let's see. So if the side lengths of the triangle are A equals 8 inches and B equals 5 inches, and I just made up anything because in this particular triangle, I counted 1, 2, 3, 4, 5. So 5 inches and 8 inches. And so basically I need to find the length of the hypotenuse. So I have c squared equals a squared is 8 squared plus b squared is 5 squared. So c squared equals 64 plus 25. C squared equals, what is 64 plus 25? Did I get that right? Yep. Clear. Okay. So 64 plus 25 is 89. 89. And in order to get rid of the c squared, now this is what we were doing in 3.7. And 3.7, we didn't meet to do that, but instead I did it on video. So make sure you go back to 3.7. I'm actually going to show you the sheet from 3.7 sometime today because it's very relevant to what we did here. So when I have this power equation, what it tells me in 3.7 is I can actually square root both sides of this. If I do the square root of c squared, then I'll have c. So that I could square root both sides. So I'll have c equals, and here for this section, you're going to need your calculator because we want you to be somewhat accurate, even though most times when you do the square root, it is an approximation, but it'll be much closer than you trying to approximate it yourself. So the square root of 89, so second square root 89 equals 9.43. Okay, and it is inches. So 9.43, the hypotenuse is the longest side. It's longer than 8 inches and it's longer than 5 inches. So that kind of holds true. And of course, you could go back and square this and square that and square that. See if you get the same thing. You could always go back and check yourself. Okay. So the next one is, I kind of threw this one in here. This one is on page 130, but I felt like I could figure this out by using the Pythagorean theorem. So that's one thing about the final is it's not necessarily going to say use the Pythagorean theorem, but if you remember, if you can make a right triangle, then the Pythagorean theorem will help you. So in this case, it says I have an equilateral triangle, page 30, number 5. With a side length of 10 feet. Well, first of all, you have to know equilateral means all the side lengths are the same. It's equilateral. So 10 feet, 10 feet, and 10 feet. And I let you know that, note, this is not drawn to scale. I did my best. I just drew what looked to be somewhat the same. but it's an equilateral triangle, 10 feet, 10 feet, 10 feet. And it says find the height of the triangle. So I'm trying to find this. Now the nice thing about the height is height means that it's perpendicular. It's the perpendicular line that goes from the top of the triangle, the top vertex down to the base, but it's perpendicular. And so that makes my triangle. Remember, the hypotenuse is opposite of the 90-degree angle. So this could be the hypotenuse. This could be one of the legs, and this could be the other leg. Well, this leg is going to be the height of my triangle, right? And I know if this is an equilateral triangle, if the whole base is 10 feet, then I know that this portion here is 5 feet, right? So 5 feet. And so I could say, let's see, c squared equals a squared plus b squared. My c squared is my hypotenuse, so 10 squared equals a squared, 5 squared plus b squared. Doesn't matter if I call the a 5 or the b 5, it doesn't matter. But in this particular case, this is my a squared, and I could call this h squared, but I'm gonna keep it as b squared, but just knowing that the b squared is equal to h for purposes of what I'm trying to do. So the h of the equilateral triangle. So I gotta be specific about that. And then basically I have 100 equals 25 plus b squared. Subtract 25 from both sides. And I have 75 equals b squared. If I take the square root of both sides, then I'll have b equals, which is my height. Square root both sides, and I have b equals the square root of 75, which is, let's see, second square root 75, 8.66 feet. So my height here equals 8.66 feet. So I found one of the legs of the right triangle, and it happens to be the height of the equilateral triangle. So this is the kind of thing that's going on in section 3.7 and in section 4.1, 4.2, and 4.3. You're gonna need to be able to use the Pythagorean theorem when it's appropriate, but you're gonna have to figure out, well, when is it appropriate? So that's why I went ahead to show you one of the exercises in your book on page 130. This is where it would be appropriate, okay? So now I'm going to follow back in the workbook. And in the workbook, it talks about the distance formula again. And it says the distance in between 2 points, x1, y1. So this is my first point. So that's why it's called x1, y1. So this is point 1, and this is point 2. And that's why we call that x2, y2, right? So the difference between 2 points, I'll call that D. Create a right triangle with distance D, and as its D as its hypotenuse. So the example is, if I have a -1, 0 and a 1, -2. So here I have plotted my 2 points, and it says -1, 0. Let's see, -1, 0. Keep it there. And then 1, go over 1 and down 2, 1, 2. Now, I made mine so that, I don't know if you can see my grid, but I made it so that it's sort of skipping everyone because I wanted you to be able to see it. Now, it says create a right triangle with D. I'm trying to find this. This is my D. And my D is also my hypotenuse. Okay, so if you think about it, I could make different right triangles. I could make a right triangle like this, down and over, or I can make it over and down. It won't matter which one you do. It won't matter. You'll still get the same, it's still the same hypotenuse. So I'm going to make mine over and down. Okay? Over and down. Now, because I have grid paper and because I have points that are right on one of the lines of the grid system, the coordinate grid system, it's easy for me. I could actually just count. I could tell what's my A and my B. This is my C, my hypotenuse. I don't know that length. But here I know my length is 1, 2, and here I know my length is 1, 2. So if you use grid paper and your points are right on the horizontal and vertical lines, then it's going to be pretty easy for you to find your A and your B. But I want to show you anyway how to find it with using math. So this is my C squared equals A squared plus B squared. But the distance formula says if I have two ordered pairs, I need to say, and I should have written it out first, I need to say x1 minus, let's see, x2 minus x1 plus y2 minus y1. Where could I write that at? So what I'm going to do is x2 minus x1 squared plus y2 minus y1 squared, and that is equal to d squared. Now, why is that true? Because basically it's saying, if I take, where's my first point? If this is my first point, this is my second, it's saying subtract 1 minus a negative 1, and that's this. That's the difference between the 2 points. It's basically saying, where did I end up? And subtract where I started, and that tells me the distance. Okay? So here I have 1 minus a negative 1. That's the difference between my x coordinates, which is going to be 2. In this case, we just counted it. And then my y difference is negative 2 minus 0. Now remember, in this case, when we're talking about distance, even if we have a negative, which this should have been negative, negative 2 minus 0, this should actually be negative. But it won't matter because if we have negative times negative, we still get a positive. We still get positive, right? So we have 1, 2, that's a negative 2, that's a 2 difference, and then 1, 2, that's a 2 difference as well. So anyway, here we go. So 1 minus negative 1 is like 1 plus 1 is 2. And then a negative 2 minus 0 is a negative 2. But when I square those, 2 squared is 4, 2 squared is 4, and then 4 plus 4 is 8. What is that doing for me? That's my A squared plus B squared. And my C squared, or my distance squared, my D squared is what I'm trying to find out. So my D squared is equal to, D squared is equal to 8. D squared is equal to 8. If I square root both sides, I get D is about 2.83. That makes sense because...
Hi, I'm Dr. Shelley Jones. I'm excited to announce the 1-year anniversary of my best-selling book, Women Who Count, honoring African American women mathematicians. Meet me on Sunday, September 13th at 2 p.m. to celebrate Women Who Count because representation matters. Stay tuned for a special panel discussion with mathematicians featured in the book, giveaways including a Katherine Johnson t-shirt, and activities from the book. Please register on Eventbrite for Women Who Count's 1-year celebration.